All right, let me go full screen as well so it's a little larger. Yeah, cool. So this is Team Gravity Wells. I'll let Towfiq take it away.
Hello, we are Team Gravity Wells. We were led by Ian and consist of Aaron, Marcelle, Olivia, Shannon, and myself, Towfiq. Our data set is of traffic accidents in the continental US from 2016 to 2021. A car accident is a common occurrence on the road. Even if someone hasn't been in one, they have probably been affected by the traffic due to the accidents. Many different environmental and human factors can influence the severity of these accidents. Through multiple machine learning models, we have attempted to accurately predict the severity of traffic accidents. So the severity is measured on a scale from 1 to 4 based on the factors such as length of the road or how long cleanup will take. We chose this project based on our personal experience with car accidents and the wide range of potential benefits it can bring.
So as our team was looking on Kaggle for data sets for machine learning, the data set with details on traffic accidents within the continental US caught our eyes. And through this data set, we were able to gain more insight through the discussion tab as well. And to prepare for EDA explanatory data analysis, we removed any unnecessary columns such as no values that would be unnecessary for our project. And we also manipulated the data for visualization purposes, such as like making visualizations with the minutes after midnight or the time of day and accident severity. So above, we have a correlation heat map that is generated to show the relationships between variables in our data set. And as you can see, there's a fairly low correlation, which also made machine learning difficult. But using the visualization, we were easily able to see comparisons that would help us make more for this project as well. So to the left, we have a histogram that was produced to visualize the relationship between the time of day represented by minutes after midnight and the car accidents as well. And as you can see, there's a notable spike between the 470 mark, which consists at the time of rush hour. And another spike is at 975 minutes after midnight or 4:15 p.m. And like I said, this is attributed to rush hour because because there's a number of cars on the road and it has caused a spike in the accident count. So to the right, we have a histogram that measures the amount of car accidents on the y-axis and on the new year in the x-axis. And there is a large dip on the 194 to 195 day mark with the accident count of 125. And as the winter starts, there's an accident increase because of holidays on December 23rd to December 24th, Christmas Eve to Christmas.
Here we have a histogram showing the effect of temperature on the accident count and the severity of the accidents. Now, looking at the histogram, we can see that the highest points range from around 60 degrees to 80 degrees Fahrenheit, peaking at about 70. Now, you can also see the general distribution of our data set looking here too, as it goes from 2 to 4 to 3 to 1, with 2 being the most common and 1 being the least common. Here you can see the same pattern here. You can see the data is also skewed on the left a bit. Now, this could simply be because the data was unable to be collected for all the weather conditions, or it could just be that there are simply significantly higher severity levels for certain weather conditions. Here we have 2 chloropleth maps. One on the left being the mean accident severity by state, and the one on the right being the accident count by state. On the left, you can see that Wisconsin has the highest mean severity by state, and we don't know why this could be the case. However, it is possible that they may lack the infrastructure to deal with these kinds of accidents. And on the right, you can see that both California and Florida have the highest number on the map as well, at 54,000 and 55,000 respectively.
We use several different machine learning methods in order to achieve good accuracy for predicting the car accident severity. The first model that we tried out was KNN, which stands for K nearest neighbors, and it is a machine learning method that looks at the K nearest number of points around an input in order to classify it. K nearest neighbors works best when the data is highly clustered and also when K is equal to a number that has a modulus of 1. SVC, or Support Vector Classifier, is another machine learning model that is pretty similar to KNN. SVC splits the data using lines or curves into different sections and classifies the data by whatever section that the input point is in. Like KNN, SVC also works best when the data is highly clustered. Random forest classifier is a machine learning model that uses multiple decision trees to classify an outcome. Inputs pass through multiple decision trees to get an output, which is a majority vote from each decision tree. Neural networks is a machine learning method based on the networks of neurons in the human brain. There is an input layer, an output layer, and multiple hidden layers with nodes in between, which the inputs pass through to create an outcome similar to neurons firing in our brains.
Below are the confusion matrices that we use to visualize the accuracy and results of the different machine learning models that we tried out. So the first two matrices are of KNN and SVC, both of which rely on clustered data. And these matrices reveal that our data likely didn't cluster very well, as both these models had a large amount of incorrect predictions and both had accuracy scores of less than 50%. Looking at the remaining matrices, it is evident that random forest and neural networks were much more effective on our data set. However, random forest was still the clear winner as it achieved an accuracy of approximately 68%.
In summary, we were able to accurately predict the severity of car crashes based on various factors. In the beginning, we didn't have much programming experience, but we learned how to build machine learning models and visualizations to test traffic accident severity factors. Histograms, choropleths, and heat maps were used to measure severity with less correlation with temperature, day, year, etc. We were able to articulate and report our findings as well as identify the consequences of traffic accidents. Thank you for listening to us. Does anybody have any questions?